Typically, the skies remain serene year after year, with only occasional comets passing by, often overlooked. Yet as 2025 nears its end, NASA is operating under intense vigilance. An extraordinary lineup of not just one, but 4 significant comets is barreling into the inner solar system simultaneously, spearheaded by 3I Atlas, the third interstellar object ever identified, racing in at double the velocity of its extraterrestrial forerunners. Experts estimate the probability of such an event at a mere 1 in 384 years. Moreover, historical records show no instance of our planet enduring such an intense celestial onslaught compressed into a mere 63 days. What connects these 4 celestial bodies? And why are the globe's premier observatory systems tracking their every trajectory? The narrative of this remarkable comet cluster unfolds here. These 4 prominent comets, each substantial enough to draw the gaze of top global observatories, are igniting to life within a narrow 63-day frame. By all accounts, this qualifies as a profound anomaly. Skywatchers have scoured archives spanning hundreds of years, including vast digital astronomical databases in quest of parallels. The verdict: nothing comparable in contemporary times, with just a scattering of ambiguous accounts from bygone centuries suggesting faint resemblances. Based on analyses from up-to-date comet repositories, the likelihood of 4 such entities converging on the inner solar system in this compact time frame clocks in at roughly 1 in 384 years. This statistic serves as more than mere data. It underscores the exceptional nature of multiple luminous dynamic comets aligning so precisely. Everyone stands alone as a noteworthy phenomenon. In most eras, spotting even a lone comet visible without aid sparks widespread wonder. In this case, however, 4 are poised to hit their zenith brightness over a period briefer than 1 season. That 63-day span marks the interval during which all 4 will be concurrently vigorous and observable beyond critical luminosity levels, a benchmark unmet throughout the age of organized celestial surveillance. To scientists, this goes beyond mere fascination. It represents a real-time study in chance, orbital dynamics, and the erratic pulses of our solar neighborhood. The stunning unlikelihood of this alignment has mobilized the entire international astronomy network. Keen to document every instant of this ephemeral, irreplaceable display, each comet in this uncommon ensemble brings its distinct tale and investigative allure. C225R2, widely called Swan, emerged first among them, spotted on September 11, 2025. The very next day, it hit perihelion at Zoryo, 50 astronomical units halfway between Earth and the Sun, providing a short yet vivid opportunity for stargazers. Following close behind is C2025K1, identified via the Atlas survey, which is destined to graze even nearer to the Sun. Its closest solar pass occurs on October 8 at a scant 0.33 astronomical units, venturing within Mercury's path, a realm seldom explored by comets. Then arrives C225A6, uncovered by the Lemon survey. This visitor achieves perihelion on November 8 at 0.53 astronomical units from the Sun. Initial forecasts indicate it may gleam to magnitude 4, rendering it discernible without telescopes in clear night skies and an ideal quarry for amateur observers. Yet the star of the show remains 3I Atlas. Unearthed on July the 1st by the Atlas telescope crew in Chile, it distinguishes itself not only by its path, but by its designation as merely the third verified interstellar intruder on record. Its solar closest approach lands on October 29th at 0.36 astronomical units away. Though a more remote arc than the rest, its pace and provenance have sent ripples of excitement through astronomical circles. Collectively, these 4 form a procession threading the inner solar system, arriving in swift sequence and captivating scientists, observatory staff, and enthusiasts worldwide. Interstellar comets earn their label through their paths beyond mere composition. 3I Atlas entered on a hyperbolic course that confirms its otherworldly roots beyond question. Its computed eccentricity of 6.141 situates it well beyond the orbital bounds of native solar system bodies. It maintains a hyperbolic trajectory, forever escaping rather than looping back in a near parabola. This visitor from beyond is on an irreversible course, hurtling across the solar system at an astonishing 58 kilometers, double the pace of earlier interstellar intruders. By contrast, typical long-period comets meander along at 20 to 30 kilometers. Even 2I Boros, the prior interstellar guest, trailed at a mere 32 kilometers. Such immense velocity ensures 3I Atlas's passage through the inner solar system remains fleeting and unyielding. At this clip, the gravitational pulls from the Sun and planets exert minimal influence. Nothing in the solar system's bustle can snag something traveling so swiftly. Its approach angle is sharp, guaranteeing a clean exit to the stars. Estimates for the nucleus diameter vary from a tidy 0.32 kilometers up to potentially 5.6 kilometers, obscured by the dense dust-laden envelope around it. That envelope is enormous, measuring 26,400 by 24,700 kilometers in visible wavelengths over twice the width of Earth. In infrared views, the CO2-heavy haze extends to a radius of 348,000 kilometers, outpacing the biggest moons in our system. From velocity to dimensions, every datum underscores one truth. 3I Atlas is a true interloper racing through on a path that screams interstellar origins. Yet it's the composition, beyond mere motion or path, that truly distinguishes 3I Atlas from all known comets. When astronomers trained the Very Large Telescope and Nordic Optical Telescope on its expanding haze from Earth-based observatories, they uncovered a mix of volatiles that upends predictions. The CO2 to water ratio clocks in at about 8:1, among the steepest ratios recorded in any comet, local or foreign. In essence, CO2 drives the primary icy outbursts here, overshadowing water. This bucks the usual pattern, where water ice typically dominates as comets heat up. For 3I Atlas, activity kicked off even at 6.4 AU from the Sun, where water ice hardly activates, fueled by CO2's straightforward vaporization in frigid voids. The shocks extend past the ices. Detailed spectra show strong nickel vapor signals with scant iron traces, a pairing almost unheard of in solar system comets. The lopsided nickel-to-iron balance upends established theories on comet makeup and origins. Cyanide gas appears too, with output surging as it nears the inner realms. These traits hint at a birthplace abundant in carbon and metals, perhaps around the CO2 ice line of some ancient, vanished star. The molecular signature evokes a protoplanetary disk utterly unlike ours. Fresh spectral data heightens the push for worldwide observation efforts as experts race to snag every detail before 3I Atlas slips back into the void. Hours after Atlas first spotted it, a worldwide confirmation rush ignited. NASA's tests patrolling for exoplanets yielded pre-detection shots from May and June, proving 3I Atlas was already stirring at 6.4 AU, well outside the usual awakening zone for comets. The following day, alerts flew to 31 facilities across 5 continents. Ranging from the Deep Random Survey in the south to Lowell Observatory in Arizona, every outpost contributed precise positional measurements, all routed to the Minor Planet Center. In a mere 4 days, 122 distinct sightings nailed the object's route and velocity. This well-oiled global web, sharpened by asteroid warnings and quick-look hunts, delivered the swiftest verification ever for an interstellar wanderer. Hubble zeroed in on 3I Atlas on July 21st, snapping crisp images from 207 million miles distant. Mere weeks on, the James Webb Space Telescope lined up a comprehensive spectral study for August, zeroing in at 3.32 AU. Upcoming assets like Sphere-X, Vera, Rubin, and Swift stand ready to join the fray. Scientists from various agencies united in the initiative, deploying their specialized equipment to examine the comet cluster closely. The Planetary Defense Coordination Office executed fresh simulations of potential hazards, verifying that despite risks of breakup, the closest approaches will stay well outside. 1.6 astronomical units. Experts keep a vigilant eye on any unexpected flares, yet current observations indicate a steady trajectory. The worldwide array of spacecraft remains on alert, gazes locked skyward, anticipating revelations that might transform our understanding of comets and distant cosmic realms. During the final months of 2025, 4 prominent comets, among them the interstellar 3I Atlas, will ignite within a compact 63-day period, an alignment that happens just once per 384 years. Based on tracking data, 3I Atlas has been validated through 122 separate sightings from 31 facilities, traveling at 58 km along a hyperbolic path and displaying a carbon dioxide to water ratio of 8.1, one of the most elevated ratios recorded to date. This comet's premature activation at 6.4 astronomical units in its atypical composition are testing established theories on how comets form. However, essential aspects like the exact dimensions of its core and the sources of its volatile compounds are still mysteries. Although no collision danger exists, NASA, alongside global collaborators, persists in joint surveillance using Hubble, JWST, and terrestrial observation arrays. The 2025 Comet Cluster is pushing the frontiers of cometary research while highlighting humanity's ability to mobilize swiftly for scientific pursuits. With incoming information still flowing, the narrative of these exceptional celestial guests continues to develop, rooted in solid data and persistent exploration.